For our next subject, we're going to talk about aneuploidy, mosaicism, embryo selection. What should patients know? This is something that we've really focused on here at CHR, and
critically,
yeah. So
yeah.
a lot of our colleagues have been, culturing embryos out to blast, doing biopsies of 5 or 6 cells, doing a very sophisticated analysis of the chromosomal genetic components of the embryo, and using it to help guide what they do. But we've been looking at that somewhat critically.
Yeah, it's the concept behind preimplantation genetic testing for aneuploidy, or PGTA, as it is called these days. It used to have different names in earlier days. But the basic concept has been, again, as we just discussed before, embryo selection. The idea being that by eliminating chromosomally abnormal embryos from transfer, the remaining embryos will give us better pregnancy and live birth rates. And that was nonsense from the very beginning, but it took years for the field to understand that, because obviously the cumulative pregnancy chance of an IVF cycle is determined the moment you retrieve eggs and you make embryos, period. Now, whether you transfer some of them earlier or a little later doesn't change the cumulative pregnancy of that embryo cohort. All it may do is it may give you a pregnancy a month earlier or a month later. And unbelievably, it took over a decade for the field to acknowledge that. And only after we and some very few others were making the point that this also doesn't make any sense to have embryos undergo this kind of testing. Now, at least that point is widely recognized, and that is appreciated. But chromosomal testing is still widely performed, even though ASRM finally, after almost 20 years, at the end of last year, 2024, came out with a final policy statement making the point that PGT-A does not do anything. It doesn't improve anything. But even ASRM was not willing to go the next step and then say, okay, if it doesn't do anything and costs $5,000 or $7,000, why are we doing it, right? So, therefore, over or close to 50% of all IVF cycles in the US still undergo PGTA testing.
When you look at it, patients need to make a decision about whether they're going to do PGTA or not when they're starting their cycle.
Yeah.
And when you look at any PGTA study based on an intention to treat basis, which is when patients are making these decisions, there's no evidence that it improves really anything, not even time to pregnancy, because you have to wait at least a month for another cycle to do your transfer, because at least the biopsy out takes time to get the result back. I remember when we were in the old days when we were doing some genetic testing on our embryos, we were already taking care of a lot of older patients. And I had all these patients that were getting pregnant when we were just doing the transfer, and then I was told we couldn't do the transfer because the biopsy was abnormal. It didn't make any sense to me. And ultimately, we had some that had abnormal transfers and double biopsies, and we did the transfer anyway, and they did fine.
Right. And I think early on, to our collective credit, there was a fundamental technological question that we asked, because there'd always been the assumption that this biopsy, which is removing 5 or 7 cells from the trifectoderm, okay, that itself could not represent the genetic composition of the inner cell mass or that you would need to entertain that there was diversity in the genetic composition of the trifectodermal cells. Something, by the way, that was evident in the literature back in the old days of fish, okay? But somehow it got swept under the rug,
Yeah.
okay? And the assumption was made that every cell that would be biopsied would be representative, would represent the constitution of the embryo, the fetus, etc. And that's turned out not to be the case. So many studies now have shown how heterogeneous this is. And interestingly, besides the cases that we've reported where abnormalities did result in a live birth, there are more and more re-biopsy studies showing that an initial mosaic or true aneuploid biopsy can be followed by recognition of a euploid secondary biopsy at baby. Okay, so that just some of the fundamental principles that this whole idea were built on were flawed to begin with.
Actually, the introduction of the concept of mosaicism in 2016 by the PGS International Society was the result of our first reports of healthy pregnancies born after transfer of allegedly chromosomally abnormal embryos. That was a big shock to proponents of PGTA or PGS as it was called then. And they thought they would solve it with the introduction of the concept of mosaicism. But here's the most bizarre thing about that. This was introduced by mostly geneticists. The genetic biological definition of mosaicism exists for 100 years or I don't know how long, but for very long, and is the presence of more than one cell lineage in one organism that arose from a single cell. That is the biological definition of the word mosaicism. Yet, the whole IVF field, led by our genetics colleagues who are running the laboratories, in IVF practice, does not define mosaicism in that way. It defines mosaicism, as you said, based on 5, 6, 8, maybe 10 cells. And if there is more than one cell lineage in those 6, 7, 8, 10 cells, that's called a mosaicism. And that is absolutely bizarre. It doesn't even meet the basic correct definition of biological mosaicism. And yet, this is how what this whole practice is built on.
So back 15 years ago, so I was at the ASRM, they were part of one of the PGD conferences, and I said, what about mosaicism? And they said, what? Doesn't exist.
That was the initial line, before they introduced it, yes. It was 2%. They quoted it exists only in 2% of embryos, yeah. And that is the amazing thing to me. We are reproductive endocrinologists. Very few of us are geneticists in parallel. And therefore, we trusted our genetics colleagues. And it turned out that they really had absolutely no idea what they were talking about. You know?
So the question that they asked was, aneuploidy, mosaicism, and embryo selection, what should patients know? So the bottom line in terms of, if you have done the PGTA and you've got these results from your biopsy, you should know that an embryo that appears to be euploid on PGTA, yes, has a very high chance, or has the highest chance of being successful. But an embryo that has mosaicism or segmental changes has a pretty good chance, maybe about 2/3 of the fully euploid one. And even those that are fully aneuploid still has a possibility of
Right.
success
Absolutely.
because of
Should not be
Technical errors.
outrightly
Yeah, right.
thrown out,
Right,
you know.
right.
so.
Yeah, and as I said before, even ASRM now acknowledges that there's really no advantage to this test. There are now new ideas being distributed about when PGTA may work. Bizarrely, I mean, the one population where it conceptually, mathematically makes least sense to believe that PGTA could work is in poor prognosis patients. And suddenly now, some papers have come out to show that in older patients, out of all the patients, in older patients, not in younger ones, but in older patients, PGTA really improves outcome. That is so counterintuitively idiotic that it is hard to believe that one would even accept the concept of such a study. But yet we still had to do another study, which we are just submitting for publication, to show that this is just not the case, you know. And anyway, I think
More on that later.
we are over our time on this subject.